This is problem 32 of Neetcode 150, LRU Cache. LRU least recently used element in a cache. In this problem, we are going to have to basically complement the class LRU Cache, and we are going to have to create a method get put, and we're also going to have to create the init method. Okay, so we have to make sure that we are using a time complexity of big O of 1 for the get and the put. And also we can use a space complexity of big O of n. So this is a hint that we can use a hash map to solve this problem. And basically we are going to create our cache. The structure, the data structure of the cache is basically going to be a hash map. And now the thing we have to actually take into account is that we need to remember what is the least recently used element. So let's say that you are browsing on Brave or Tor and that you went through 10 websites. Let's say that you have you can add a maximum of 10 windows on your browser tab, and when you open the 11th one, the least recently used, so the one you first use, and well, it's not necessarily the first one you use, but if you use the 9 others before that one window you didn't use, well, this makes that one window the least recently used one. So we are gonna have to remove that least recently used one. Okay, so let's go ahead and try to solve this problem. Let's first actually conceptualize it. So we are gonna have a hash map, and in each key we are gonna have basically the value of the element that we are adding, and we are also gonna have the value, and the value is basically gonna be the entire node. So it will contain a next pointer, a previous pointer, and a value. Okay, so in this problem, what we are actually adding in the cache is not windows in a browser, it is actually numbers. So it is a little bit simpler. We are dealing with numbers. Our keys will be numbers, and we are gonna have to deal with that and try to find a way to remember the least used element. And we also have to create the necessary code to remove the element that is the least recently used. Let's just click on this link to give you an example. For example, if we add a with a value of 0, we have 4 places in our cache, so we can allow ourselves to add b with the value of 1, then c to the value of 2, then d to the value with the value of 3. After this, we can see that our cache is full. So if we never went back to that a with the value of 0, it makes that a with the value of 0 the least used element in that cache. So when we want to add our e with the value of 4, we are actually going to remove that a with the value of o and put that e with the value of 4. Now it is possible that in our problem we are given the actual same value. For example, here we are given d twice, but d has a different value. So we are going to have to handle cases where we can where we have to update something that is already in the cache. And lastly, if we never came back to our B1 after inserting it at first, it will be the least recently used element. So if we want to add another key another key f, pardon me, we are going to have to remove B with the value of 1 to add F with the value of 6. I hope this is a little bit clearer, and let's conceptualize how we can find the least used element. We are at the least yes, the least the LRU element in this problem. So let's create a double link list node. Okay, so for each value, so we have, let's say, node n will stands for node. Okay, so we have node 1 that will point to node 2, which will also point to node 3, and we are going to use a double linked list, so each values will also point back to that previous value, just like this. Okay, so by doing this, we can keep track of that initial element, right? So let's say that we first start with let's say we create like a left here, so let's call this L, which will basically point to the first element, which is our least used or least recently used element, and we have a right here with the pointing to the most used element. Okay, and in the case where our cache is full and we want to add another value, we are just going to remove this first element. Okay, so we are going to say left.next, and we are going to get access to that node 1, which is the thing to remove in the cache. All right, and after this, if you want to what is great with this double linked technique is that if we want to insert an element, um, or update an element, well, we can simply um, basically, let's say we want to have like n 1.5, we just have to um, change the links so that the n1 points to n1.5, and n1.5 points to n2, n2 points to n1.5, and this way we can actually update or insert an element, um, and there you go. So if we insert a new element, of course we are gonna have to insert it at the right, because it will become the most recently used element. But if we want to update it, we can just use this technique, and with the double linked list, um, we actually can access pretty easily the previous value or the next value. So this is why we are using a double linked list, is mainly because we want to access the previous and the next value. Okay, so first, since our since the values of our keys in our hash map or in our cache will represent the entire node, I will create a new class called node. And basically, I will create just an init method, so def init. All right. And what do we want actually our node to keep track of? Um, we will, well, basically the arguments are going to be the key and the values. So let's just define them. So self.key, self.val, it's going to be equal to key and val respectively. Okay. And after this, we are initially gonna set the previous pointer and the next pointer to none. So at least they start with an init. They don't. So by setting them to none, we are actually gonna create like an initial state upon which we can update it. So we actually have to to define them. So we are going to define what next and prev is. So we are going to say that self.prev and also self.next. So we are going to set both to none at first. So after this, we can go ahead and update it any further if needed. So once this is done, we can actually jump to the class LRU cache, and we have to define what is in it. So inside the constructor, well, basically we want to have our capacity, right? So um, the capacity is going to be given to us. Um, so we can simply say self that capacity is equal to the capacity. And this is also where we want to create the cache. So the cache is gonna have a data structure of a hash map. Okay. Now we can actually um, define, the left and the right pointer. The left pointer, which is gonna point to the least recently used element, and the right pointer is gonna point to the most recently used element. Okay. And we are gonna set basically this stage also for what their next value is and what the previous value is, right? We don't want to have a previous value to the left because it only has to point to the next one, which will represent the LRU, and the right is gonna have to have a previous value, not a next one, because the previous is gonna be the MRU. So let's go ahead and say self at left and also set the right. Okay, and let's just create a template node. Okay, so this is not where we are going to update the node with the actual inputs. We simply want to make sure that they represent something for the moment. Okay, so after this, we are going to set our self.left dot next. So this is where we are going to initially construct them, and also self dot right dot prev. All right, and let's just set them to their actual values for now. So self dot left, oh, self dot right. So they are, so the self dot left as next value is going to be the self dot right. Okay, so we are just going to have a linked list with two values for now, and also we have to make sure that the previous value of the self dot right is the left value. So self dot left. Okay. All right. So now we have a linked list with two values. We have the left and the right, and the left points to the right. The right points to the left. And after this, we are actually capable to move to the get. Okay. So we actually want to in our double linked list, we want to remove the value that was currently in the linked list, and we want to add it at the end. So basically, we are going to be willing to remove that value in the double linked list, and after this, we are going to take the value at the right and set that previous value pointing to that new value that we just used, and that new value pointing to the right one, so we can update our MRU. So let me create, I think this is going to be the most efficient way. I will create a function to remove. Let me just call it rem. All right. And this is going to take a node, right? So it will remove the entire node in the linked list. And let's also define something we can like add or insert. Let's just say add, which will take also a node, right? So we are gonna add the new node to the end of the double linked list. Okay, so let's just continue with the assumption that we have these functions, and now let's actually define what we are gonna do in in get. All right, so um, first, we have to make sure that the key we are trying to get is actually in the cache, because they are saying that it might not be in the cache. Otherwise, we are gonna have to return -1. So we are gonna do this by saying if key, um, pardon me, if key is in the cache, and since okay, so if key is in the cache, all right, we are gonna do something. Otherwise, we are gonna return -1. Okay, so let's actually write what is the something here. Um, we are gonna um, we are gonna use basically our remove function. All right, and after this, we are gonna be willing to insert the value we just got at the end, so that it becomes the most not at the end, but at the right end of the double linked list, right? Because we know that the right end represents the most recently used element, so we have to put it at like the most right element. So we are gonna say self dot add, and later on we're gonna define our add so that it actually adds the element at the most right. Okay, so now self dot remove. Um, well, we have to um, we are basically just um, gonna be willing to pass the node, right? So we are gonna basically just say self, and we're gonna take the cache at the key value that we are given. So self dot cache key. So this way we can get the entire node, and this is the same thing here. Self dot cache at key. Okay. So right, we also have to return that value, okay, because we want to actually get that value. Um, so we're gonna say self, right, that cache at the key that we are willing to get, and actually the value itself is an entire node, right? And within that node, we know we have the value, and we want only to return that value. So they're not asking us to return the entire node. We want to return the value. So just like this, that val, okay? So by doing this, we get the value itself. So if we inserted 3, and 3 is the value you want to get, well, we are going to receive 3, okay? And now what is put? So what goes inside put? Um, well, there are two options, okay? The first one is that the key is already in cache, or if key is not in cache. Okay, so let's let's first say if key is in cache. All right. Well, what we are going to be willing to do if it is in the cache, we are going to be willing to actually remove it from the cache. Um, not remove it from the cache, pardon me, but remove it from the double linked list, because putting a value itself um, is considered equivalent to basically getting a value. So it has to become our most recently used element. All right. So if the key is in the cache, we are going to be willing to remove it. So we are going to call our rem function, and we are going to pass the node of the cache at that key. Whoop. All right. Okay. And then regardless, well, after this if statement, basically that key should no longer be in the cache. Um, and we are gonna say, and we are gonna add in the cache. Um, well, let me just re-explain it. Okay, so after this if statement, the key should not be in the double linked list. Okay, so we are not gonna remove it from the cache. What we are gonna say is we are just gonna update its value. So we can do this with getting the cache at the key, and we are just gonna say node key value. So we actually don't need to remove it from the cache, but we have to remove it from the double linked list so that it becomes the most recently used element. And we're going to do this by calling our method in add with the node. So we're going to pass the node, which is the value of the cache at that key, right? Okay, so great. So now we check basically if the key is in the cache. If it is, we are going to remove that key within the double linked list. After this, we are going to update its value in the cache, and we are going to add it as the most recently used element. Great. I hope this is a little bit clearer. And great. Now, when we put a value, we have to be careful because it is possible that we are adding a value, but our cache is already full. So we are going to say if the length of the cache, so right. So if this is greater, well, after adding the new key and node inside the cache, which is I recall a hash map, we might gonna get an extra value, meaning that the length of the cache is gonna be greater than the capacity. And if you recall in our init function, we actually set that capacity, and it is given to us. So if this is greater than the capacity, right? Um, well, first of all, we have to get the least recently used element, right? And what is the least recently used element? Well, I know for sure that that the left function, right, is going to be pointing to the most left element, so the least recently used element, right? So the cell that left is a dummy node here that is just there to point to the left element in the double linked list. So we are going to say that the least recently used element is um, the next value of left, right? Okay, so now that we have the least recently used element, we are going to call the or method remove, which I recall we are going to have to code this a little bit later because now we're using it. We're assuming that it exists. Okay, and after this, we have to remove from the cache. Um, we have to remove that value from the cache, so key and node. So we can do this in Python by using basically del, which which is similar to popping a value, but it actually handles exception cases. So it is preferable in this case. So we are gonna remove uh, from the cache the key of the area, the least recently used element, and its value. All right. I think we're good to go with our functions. We just have to actually define what is remove. So when we want to remove, we have to keep track of the previous value and the next value. And then we have to make sure that that previous value points to that next value and that that next value points to that previous value. All right. So by doing this, we are like removing all the links between the current node and its previous value. So I hope this makes sense. But in case it doesn't, let me just well, let me just use the example that we had earlier. So right here, okay. Um, so we had a node with the value one. It was pointing um, to that value to that node two, and that node two was pointing to that node one, right? But now, if we want to remove something, like let's say we want to remove the node two, okay. Well, we are basically gonna have to take that previous value of node 2 here, or let me just do a p. It doesn't look like a p. Okay, let's just keep it like that. And also the next value, which is 3. And we are going to have to make that previous value point to that next value, and that next value point to that previous value, so that at this point there are actually no links with that n2. So it is removed. Okay, so this is exactly what we are going to do. So let's first set a previous and also a next. All right. Or no, next is a keyword, so I have to use something different. So nxt, all right, and the previous value is gonna be we're gonna set that equal to self dot well, no, it's gonna be node.prev, right? Because we are inserting the node, and the node contains a previous value. So we are gonna say that the previous value is node.prev, and what is the next value? I'll let you guess. Node.next. All right. And after this, well, prev.next, right? Prev.next. And next.prev. All right. So prev.next is gonna go is gonna go point to the next. All right, as it is. And the next itself, I wrote next again, but I have to use this short version, right? So next.prev is gonna go point to prev. Okay. All right. So by doing this, we actually created a remove method. So now we have to create a head. So when we want to create a head, we also have to take some sort of previous and next pointer. But actually, we want to add this to the top or the most right of the double linked list, because the most right represents the most recently used element, as I repeated I don't know how many times in this video. So we are basically gonna take that. Let me just use that whiteboard. Okay. So if you recall, this is our left. This is basically our right. Okay, like the R you see on the screen, and the R that prev is that value node 3. So we are gonna say that our prev is right that prev this, and prev itself and next basically is gonna be just that right value, so that our node basically is gonna point to that prev, which is let me just actually write this. So right is here, and now let's say we want to add like node 6, and we kept track that this is the prev and this is our new next. Well, this way we can actually link our prev to our new node and our node to our prev, right? So it keeps the double linked list logic, and our node is going to point to our next, and our next is going to point to our node. Okay, so this is the addition. So prev next. Already, what is prev? Prev is self. That's right. That prev. Excuse me. And next is going to be just self the right, because we never want to put a value that is to the right of right itself. All right, and prev the next. All right, and also next that prev. So nx. Pardon me, I have to use another word in next because this is a keyword. So prev next is going to be equal to next dot prev, and both of them are going to be linked to that node. All right, so now we made the first thing. Now that the first thing is made, we have to link back our node dot next and our node dot prev. All right, so node.next is going to be equal to nxt, and node.prev is going to be equal to Correct. All right. So actually, this is the code itself. Uh, Let me just try it out, see if it works. We might. Oh, we have an error. Okay. So yeah. Okay. So excuse me for this. This cannot be a comma. This is actually an equal sign. All right. So let's go ahead and oh, cool. All right. So we got it. All right. So this was problem 43 of Neetcode 150 LRU Cache. I hope you learned from this video, and I hope to see you in the next one.